Welcome everybody to the weekly Quantum World Detangled Season 1, Episode 5. Who would have believed that we'll become celebrities one day? I am joined by my friends Denise.
Hi everyone, Denise Ruffner from Cambridge Quantum Computing, coming to you from Pasadena, California. And Tommaso?
Hello, hi everyone. Good morning. Tommaso from Entropica, calling you from Singapore.
And our celebrity guest of the week, yeah.
And look who came today.
I don't think I've been called a celebrity before, but yes, Tony Uttley from Honeywell, and calling from sunny Minnesota today. So,
well, Tony, you are a celebrity in quantum, and we're excited to have you joining us from the US. So we're a little less global today. We'll need to find a guest on a different continent next time. I saw on your resume you started out at NASA, I believe, and I live down here in Miami. Actually, thinking about driving up this weekend. Tell us a little bit about that, if you don't mind.
I did, yeah. I actually worked at the Johnson Space Center in Houston, so I was part of the human space flight program. And at one point, I was the operations manager of something called the Neutral Buoyancy Laboratory, which is a 6 million gallon tank of water that NASA uses to train astronauts on how to do spacewalks. And there is a little tiny bit of celebrity in there, which is I was in the movie Armageddon. So
you were?
I am in the credits. Yeah, I am the special thanks to, I think, the very last credit, if you can wait that long, kind of Marvel style.
I once was in a movie, but I rather not say the title. That's probably better.
Let's not go there.
Let's not go there. Let's look at the quantum news, and we will come back to Tony in just a couple of minutes with some tough questions on Honeywell, of course. We don't want to do advertising here, but bring the news, and Denise is going to break that rule because that is moderator privilege.
Well, I wanted to announce to everyone that we've started an organization for all quantum startups. It's called onequantum.org, and it's a way for startups to join together and communicate and collaborate and learn from each other as part of the quantum ecosystem. We're excited. We've had a lot of people express interest in join, and we hope that all of you out there who are startups that are watching will go to onequantum.org. I feel like I'm on the radio, and check it out, and hopefully join and become part of our group. So we look forward to having you participate and learning from each other.
Well, wonderful, and maybe we'll have Tony as a guest speaker at One Quantum as well.
That'd be great.
Our favorite startup sits in Singapore. Tommaso, what do you have for us this week?
Sure. Give me 1 second. I'm going to share the page as always. So it's quite amazing. I have to make another comment. I like to check the archive almost every day, right? And when I was checking the archive a few years ago, by the way, you should see the page soon. It was quite nice because on some days you would have like 7, 8 new papers. And today I was checking the archive yesterday. There was just an endless stream of work on quantum computing and quantum information. Is just I know I've said this a few times. It's just incredibly exciting to see how things are changing fast. Can you see anything or not yet?
We can, yeah,
we can see it.
You can. Perfect. So you should be able to see a quantum native engineer's bookshelf. Can you confirm that?
Confirmed. Yes.
Beautiful. So this is Rod Van Meter's blog. He is one of the people I admire the most in the community. He's a professor at KU University, and he came up with this amazing list of books and resources that, people who want to become quantum native should most likely look at. And I quite like the fact that he says quantum computing involves mathematics, physics, and computer science, and also engineering. But it just gives such a detailed list touching on all the different topics that I think is going to be very useful for anyone who's curious about quantum computing, and they might feel a bit overwhelmed because they say, I don't know quantum mechanics, therefore I can't start. And Rod really challenges that assumption. and he does it in a very informative and a very useful way. So we can share the link later on, but I thought this was such an amazing resource that people would love to know more about it.
This is great. Thank you, Tommaso.
It's fantastic.
This is one of my big things, is always staying up to date with books on quantum. I love
It's
this.
beautiful because it's not only about quantum computing. For example, there's an introduction to optimization, to algorithms, and these are all the kind of books that people want to have on their bookshelves while they work on quantum computing. So it's simply amazing.
And I put you on the spot. This is not prepared. The first sentence said it doesn't only include mathematics, physics, and there was something else, but fourth on society.
Yes.
Which I find very interesting. I'll ask both you, Tommaso, and Tony, because both of you are building hardware and software. Have you read any books on society that help you think about quantum and deploying that? Or
I'm not sure if it's specifically about quantum, but yes, I think it's very important to, of course, not only to read books, but also to live the society part of building, in this case, a quantum computing company. There's a very interesting Chinese saying, I don't know if I'm saying it correctly, but you don't want to build a car behind closed doors. And I think here, this applies more than ever, really. I mean, you want to make sure that the technology is actually useful, it integrates with what already exists, et cetera, et cetera. So yeah, totally.
And I guess I can't say that there's a specific book that I lean on, but we have an advantage of being in so many industries already that we absolutely and unequivocally know are going to get profoundly impacted by quantum. It's a nice starting place. So when you already make chemicals, when you help do petroleum and oil and gas refining, when you help do the kind of aerospace systems builds that we do and process controls, you know that these are going to be profoundly impacted, and you can start adapting both the development of the architecture and what you have as a roadmap based on those use cases as a starting point.
So everybody, we're really excited that Tony Uttley is here with us today. So we need like a drum roll. Tony from Honeywell Quantum Systems is here. We're very excited. This is in response to last week's article from Tommaso that it's the 25th anniversary of the ion trap device. And so we thought no better way to celebrate it than to have Tony visit us and talk a little bit about what they've been doing at Honeywell. And then, of course, we have some great questions for him. So, Tony, maybe you could start off and just give us a little preview of what's going on.
Sure, happy to. So I'll start by saying in early March, we publicly said that we were going to be releasing the world's most powerful quantum computer in the next 3 months. Had no idea that we were going to get hit by a pandemic immediately following, but I am very excited to say that we are still on track to hit that announcement. So the team is extraordinary. It's just an exceptional set of human beings who are working on this and driven. And in fact, we expect to have our kind of initial engagements starting as early as next week. So it's a really fun time to be a part of Honeywell right now.
Fantastic. So we do have some news here. March, April, May, that's 3 months, right on timeline. COVID, the health crisis, but also the economic situation around it has negatively impacted the rollout.
I think like anyone around the world, you can't look outside or can't look at the news and understand what's happening. And we've had to do the same thing. So in terms of social distancing, literally redesigning our lab spaces to be able to have people separated, to be able to have physical barriers. We've put in a ton of automation that we had planned to go later so we could have people operating remotely. And then we've taken kind of the necessary steps both to keep everyone safe and healthy, but also to keep on making progress because we believe it's a race. You know, this is a race, and we want to be the winners. But we also realize that, and to the point you brought up earlier, these are technologies that have the potential to impact humankind for generations. And so the earlier you can get them and make them available for people to start really getting the value out of them, the better.
And we're not going to stick to 15 minutes today, and I know Tommaso is itching with some questions, but I have to ask as well. Sorry, Tommaso, you just said that Tony and I love that we be the winners in this race. What does it mean for you in quantum computing to be the winner?
We want to, a couple things. We want to be recognized as leaders in the quantum computing space. That starts by having people even know we exist. So that was a start. Just letting people know that we were actually developing quantum computers, which we intentionally kept under wraps for a very long time. But also, I think most importantly, focus on use cases that have value creation potential. So, and it's not, well, the way I've described it is what you have to start with is a path to value creation. No, we all know where we are right now in the industry. The important thing is, okay, if you can plot out as you scale up these systems, as you scale the quantum volume quickly, then what additional capabilities can you do? What does that path look like between now and 12 months from now, 24 months from now? And again, just as a size company that we are, we understand that a lot of industries, the development cycle for their offerings are years long, sometimes decades long. You don't plan right now on where you can insert quantum computing into that development cycle, you're going to already be too late.
I agree. That's a great point, Tony. I think it's one we make all the time, or one certainly I try to make all the time. But I want to hand it over to Tommaso, because I know he has questions. So Tommaso, what are your questions for Tony?
Sure, thanks. All right. I mean, I like the fact that you think about it as a race. Then, when you're racing, you're racing against other, let's say, opponents, other players as well. I think it's very unique about quantum computing that we know there are different ways you can encode or you can build a qubit physically. And I think it's fantastic that there are different companies exploring different architectures in that sense. So ion traps are, let me start being a little bit provocative from the beginning. So ion traps have been the technology of tomorrow for like 10 years now. So do you think there is something still missing for ion traps to start entering the market, let me say for real, meaning with having a large group of people actually using these machines? And do you also think there is something uniquely special about the architecture that other architectures are missing?
I do. And it was a conscious choice to pick trapped ion as the underlying architecture. And it was, and I would even push back and say, it's not 10 years, it's 20 years, right? The concept, even what we demonstrated with our QCCD architecture, that's not new. That has been around for a while. It's hard. And I don't say that as anything but that's a really good thing in quantum computing, because if you find a way to make it work, then it gives a pretty substantial advantage. And Honeywell, that's kind of what we do. We are controls experts, complex system integrators, and we went down a path to take some of those really heavy technical debt pieces on early, so that as we release our first commercial quantum computer, we can scale it up quickly. And so we are tremendously excited to be able to have our partners and customers start engaging with us and using our systems.
Nice. And maybe I have a follow-up question to that, if you don't mind. One of the features of ion traps, or trapped ions, compared to, in this case, superconducting chips, also photonic chips, is that they are slow. For the benefit of everyone listening, it's very important to think about computers also in terms of clock speed. So how many operations they can actually perform in a definite time, let's say a second. And ion traps are much slower, many order of magnitude slower than a superconducting quantum chip in this case. Do you think this is going to be a limitation, in the short and medium term? Because if I have to wait, let's say for, of course, this is an arbitrary amount of time, for a month to get a result, will I be willing to wait for that long, even if it is really a valuable problem that I'm trying to solve?
I love that question. I'm glad you asked it, because it's something that we get frequently. And so let's go with the numbers, right? If you're doing a superconducting circuit, you're talking about kind of nanoseconds of computation. If you are using trapped ion, you're talking about microseconds. So 1,000, you're 1,000 times slower. Okay, so is that matter in the long term? Well, it depends. So the next question you have to ask is, what is your coherence time? And what is the ratio of your coherence time to your computation time? Looking at coherence time of superconducting, now you're talking about microseconds. If you're talking about coherence time of trapped ion, you're talking about seconds. So you have 100,000, somewhere between 10,000 and 100,000 times difference from superconducting. And so what ends up happening is that your computation time to your coherence time ends up being somewhere between 10 and 100 times better in trapped ion. It also allows you to do some pretty novel things, like this mid-circuit measurement, where you're pausing, right? You're basically stopping the computation, interrogating a qubit and saying, depending upon if you're a 0 or a 1 right now, I'm going to go change what I'm doing with the rest of that circuit. That's really only something that can be done right now using trapped ion technology. And so when you think all that through and say, what am I comparing it to? Then if the next best alternative is a classical resource that would take 1,000 years to do, and you can do the computation in 2 weeks, you're probably willing to wait. It depends on what you're doing. If you're putting it into a real-time operation, clearly that doesn't work. But if the next best alternative is you could never have done it in a reasonable lifetime, then it starts to be something that has to be considered. And certainly in the near term, I'll say the next kind of 5 years or so, that's not going to be the limiting factor.
Thank you. Nice. Last question, if no one minds. When do you think we're going to have 1,000 qubits?
I don't know. I don't know. I would say I could show you our roadmap, but I won't. Do I think that is an impossible thing to do in the next decade? I don't. I think that is a very possible thing. But it really comes down to, can you have a high enough set of quality qubits? Can you do the, at least in terms of trapped ion, kind of an all-to-all entanglement to get the value out of that? Can you have a long enough coherence time to start doing meaningfully deep circuits? And if the answer is yes, to each of those things, you really start to cross into that threshold of advantage, right? Where I've typically called it something else, which is this classically impractical era, which is, sure, you may have been able to do it with classical resources, but you wouldn't wait. You wouldn't wait that long. You wouldn't pay that much. And so doing this co-processing of classical resources and quantum to pull out that piece where it really becomes a QPU, a quantum processing unit for that one piece of the job, we believe that's going to make a meaningful advantage.
Fascinating, and I think I speak for both Denise and I when I say it's a privilege to even just listen to people like you, Tony, and Tommaso, really building the future. You heard it here, first time post-COVID. Honeywell is out of the gate to win. Customers maybe as early as next week, and more of the Honeywell machine coming shortly thereafter. Very exciting. Thank you very much. If you are a quantum tech startup, don't forget to join Denise and my new venture at onequantum.org. It's $10 a month, and we offer you a ton of resources on sales, marketing, fundraising, as well as a safe space to collaborate and exchange. Tony, thank you again. We will invite you back if you accept to reveal your roadmap. At that point, this was the Quantum Week. I forget our title. So exciting. The Weekly Quantum World Detangled, Season 1, Episode 4. You are now detangled.